Packet Tracer. Implement REST APIs with an SDN controller. Addressing table. All subnet masks are 24. 255, 255, 255, 0. 3 routers. These 3 routers. Switches. These switches. And devices. And devices. The example server and the controller. In this packet tracer activity, you will use the packet tracer network controller and associated API documentation to send REST requests from Postman and from Visual Studio Code, VS Code. Packet tracer also supports a Python coding environment. Therefore, in the final part of this activity, you will send REST requests from within packet tracer. Required resources: one PC with operating system of your choice, VirtualBox or VMware, DevNet Associate Virtual Machine. Launch the DevNet Associate Virtual Machine. If you have not already completed the lab, install the Virtual Machine Lab environment. Do so now. If you have already completed that lab, launch the DevNet Associate Virtual Machine now. Okay, and go to VirtualBox. Verify the network connectivity, right-click Settings. On Network should be NAT and Advanced Cable Connected. Okay, be sure cable connected. Okay, then start the virtual machine. Ready. Verify external connectivity to Packet Tracer. You will verify that Packet Tracer can be accessed by other applications on the DevNet Associate Virtual Machine. This activity must be completed entirely within the DevNet Associate Virtual Machine environment. Support for other setups is not provided. If you have not done so already, open the Packet Tracer activity. Within the DevNet Associate Virtual Machine, access your course curriculum in the Chromium browser. Navigate to the page for this activity. Download and launch the file Packet Tracer. Implement REST APIs with an SDN controller associated with these instructions. Download the file from the video's description. Okay, look at the description and download the file. Okay, this is the downloaded file. Okay, this is the file. I will use Google Drive to send the file to the virtual machine. Okay, this file. Okay, very good. Then on the virtual machine, go to Chromium browser. Go to Google Drive. Okay, this is the file. Download the file. Okay, and open Packet Tracer. User login if you have a NetAcad account, or guest login if you don't have a NetAcad account. I will use user login. Okay, and file, open, go to DevNet associate directory, downloads. This is the file. Open. Okay, very good. Okay, the packet tracer file is open on the DevNet associate virtual machine. Verify packet tracer settings for external access. Options, preferences, miscellaneous. Options, preferences, miscellaneous. Under external network access, here external network access, verify that enable external access for network controller REST APIs is checked. Okay, be sure enable external access for network controller REST API is checked. Close preferences window. Okay. Click on controller config. Click on controller config. Real world controller. Real world controller. Check access enable. Okay, check access enable. Click here. Okay. Make note of the port number, which is most likely 58,000. Okay, HTTP port 58,000. And the server status should be listening on port 58,000. This is the port number you will need when externally accessing the packet tracer activity from Chromium, Visual Studio Code, and Postman later in this activity. Verify you can access packet tracer from another program on the DevNet associate virtual machine. Open Chromium and navigate to http://localhost:58,000 API/v1/host. Okay, on the DevNet associate virtual machine. Okay, Chromium browser on DevNet associate virtual machine. HTTP column / localhost column 58,000 / API / B1 / host. Okay, very good. Be careful, enter. Very nice. The response: security authentication failure, error code, external access, message authorization, empty ticket. Version 1. You will get the following response. This step verifies that you can externally access Packet Tracer and controller. Notice that authorization requires a ticket. You will get an authorization token in the next part. Okay, this is the same response and request an authentication token with Postman. You will investigate the REST API documentation in Packet Tracer and use Postman to request an authentication token from the controller. You can also do this in Visual Studio Code with a Python script. Investigate a REST API documentation for the network controller. To see the REST API documentation for controller, complete the following steps. Admin desktop web browser. Okay, on Packet Tracer activity, go to admin PC, click here, desktop, and web browser. Enter the IP address of the controller 192.168.1.1.254. This IP 192.168.1.1.254. Go to admin 192.168.1.1.254. Go. Very nice. Login into controller, user Cisco, password Cisco123 exclamation mark. Username Cisco, password Cisco123 exclamation mark. Okay, and login. Very good. Click the menu next to the Cisco logo and choose API Docs. Click here, API Docs. Very good. You can also access this same documentation from the Help menu, Help Contents. Okay, you can access also using Help and Contents. But anyway, I have this. Okay. Okay, scroll down and go to Network Controller API. Okay, this is already selected the network controller. In the API documentation, click Add Ticket. Click here on Tickets, Add Ticket. Okay, the first Add Ticket. some REST API functionality may not be available in the current version of Packet Tracer. Create a new post request. After reviewing the add-ticket REST API method documentation, open Postman. Okay, review. A ticket, this method is used to create a new user ticket. Okay, the parameters, you can use a CURL, post, parameters, body parameters, required password and username, password and username. And the responses, 200 success, 201, and 400. The client made a request that the server could not understand. 401, not authorized yet. 500, the server could not fulfill the request. 501, the server has not implemented the functionality. 201, the post request was fulfilled. Okay. And open Postman. Okay, in DevNet associate virtual machine, open Postman. Applications all. Postman. Okay. In the launch area, click the plus sign to create a new untitled request. Here, this sign, plus sign, click here, untitled request, new untitled request. Click the down arrow and change the type from get to post. Okay, change this to post, post, post. Enter the URL http://localhost 58,000 API v1 ticket. http://localhost 58,000 API v1 slash ticket. Okay, verify. Be careful. Okay, very good. Below the URL field, click body, change the type to raw. Okay, click here on body, click on raw. Raw. Very good. Click the down arrow next to text and change it to JSON. Okay. Change from text to JSON. Very nice. Raw and JSON. This change will also set the content type HTTP header to application JSON that is required for this API call. Paste the following JSON object into the body field. Make sure your code is properly formatted. Okay, you can copy uh, select this, Control C, Control C. I cannot use right click, just only Control C and paste. Very nice. Be careful. Username is Cisco. Uh, be careful, comma. Password Cisco123 exclamation mark. Okay, this is very good. Now you can see. Send the post request. Click send to send the post request to the controller. You should get a response similar to the following. However, your service ticket will be an actual value. The response, the idle timeout, and the service ticket. This is the ticket and session timeout and version. Okay, and send. Send. And review the response here. This is idle timeout, service ticket. This is the ticket or the token, session timeout and version. Very good. Copy the service ticket value without the quotes to a text file for later use. Okay, copy this to Notepad. Copy. Go to menu and search Pluma. This Pluma, the Notepad of the DevNet Associate Virtual Machine, and paste. Very nice. Send REST request with Postman. You will use your service ticket to send 3 REST requests to the controller. Create a new GET request for all network devices in the network. In Postman, click the plus sign to create a new untitled request. Okay, go to Postman, plus sign, click here, new untitled request. Enter the URL http localhost 58000 API v1 network-device. http :// localhost 58000 API v1 network-device. Okay, be careful, network-device. Very good. Below URL, click headers. Okay, click headers. Under the last key, click the key field and enter X authorization token. Click here on the last, the empty key, X dash out and token. Case sensitive. Okay, X uppercase, A uppercase, T uppercase. In the value field, enter the value for your service ticket. Here on value, go to Pluma and copy this, the token or service ticket. Okay, ready. Send the GET request. Click Send to send the GET request to the controller. Okay, the URL, the headers, GET, the token, the value, and send. Okay, you will get this response. You should get a response listing the details that the controller has for the 9 network devices in the network. The response for the first device is shown here. Okay. Okay, for example, connected network device IP address. This is an interface on the router R1. This go to Postman, the IP address of the controller, IP address of the example server, controller, example server, the names R1, controller, example server, and those devices are connected to the switch SWL1. Okay, these 3 devices are connected to the switch SWL1. The ports. Okay, another network. This IP address is 1.1.2 and 1.1. Okay, 1.1.2 is the switch SWL1 and 1.1 is the router R3. Switch SWL1 and router R3. Those devices are connected to R1. Those devices are connected to R1. More IP addresses. 10.0.1.2, 192.168.1.2, 192.168.2.2. 10.0.1.2, 192.168.1.2, and 192.168.2.2. SWR1, R1, and R2. SWR1, SWR2, R1, and R2. Those devices are connected to R3. Those devices are connected to R3. Okay, and so on. All the topology. All the topology. Duplicate the GET request and modify it for all hosts on the network. Okay, and the GET request is for network device. Duplicate this, right click, duplicate tab. Okay, get the URL headers, the token. Very good, but do the following. All information in the ticket is the same except for the URL. Simply change network-device to host. Host. Okay, instead of network device, use host. Send get request. Send. This is the response. You should get a response listing the details that the controller has for the 6 host devices in the network. Okay, for example, host IP 192.168.1.023. PC4 192.168.1.023 is connected to switch SWL2, connected to switch SWL2, PC4, MAC address, another device, 10.0.2.130, 10.0.2.130, PC3. PC3 is connected to switch SWR4, connected to switch SWR4, and so on for the hosts. Okay, this is the example server. Very nice. Close Postman to free up memory in the DevNet associate virtual machine. Okay, close Postman. Send REST request with Visual Studio Code. You will use Python script in Visual Studio Code to send the same API requests you send in Postman. However, you will also use Python for loops to parse the JSON and display only specific key value pairs. Use a script to request a service ticket. Okay, open Visual Studio Code. Okay, this open Visual Studio Code. File, open folder, navigate DevNet source, ptna. File, open folder, down here. DevNet source, ptna. Okay, open. Notice in the Explore pane on the left that three scripts are shown: get ticket, get network device, get host. Review the code for each. Notice that the scripts for the network devices and hosts require that you replace your service ticket value with the value Packet Tracer gave you when you request a ticket. Request a new service ticket to see the function of the getTicket script. Okay, first verify this is the ptna directory with three files. Open terminal window in Visual Studio Code, terminal, new terminal. Okay, terminal, new terminal. So you have a new terminal on the DevNet source and ptna directory. And run the getTicket file, Python 3 and the name getTicket. Okay, but first review the file. The first file, getTicket, the first file. Import JSON, import request, the URL is ticket. Okay, the headers, content type, application JSON. The body of JSON, this for authentication username and password. Then request post method. The URL is this, body JSON is this, the headers is this, verify false to avoid SSL certificates, print the status code and print the response. Okay, Python 3 space 01 underscore, press tab to complete, enter. Okay, this is the status and the service ticket. Copy this, copy. Go to Pluma, enter and paste. It's a different ticket, as you can see. Different ticket. Replace your service ticket value in get network device and get host with the value Packet Tracer gave you. Okay, this is the ticket. Copy and go to file number 2, network device. Replace here. Okay, the headers, the authentication token will replace here. Very good. Save and go to file number 3, get host, and replace the ticket here. Paste, very nice. And don't forget to save. Use a script to request a list of network devices. Previously in Postman, the call to the network devices API returned a list of all 9 network devices and all the information available for each device. However, the network device script prints only the values of the keys that the programmer is interested in: hostname, platform ID, and management IP address. In the terminal, run the get network device script, the file number 2. Okay. Okay, go to file number 2 and review. JSON request the URL, network device, the token, the request is get method, the URL. The URL is this, the headers, the token, the headers, verify false, print the status, response, and use for to get the output. Only get the hostname, the platform ID, and management IP address. Okay. Don't forget to save and run the script. 5.3.02 tab to complete. Get network device, enter. And now you can see the output. 1, 2, 3, 4, 5, 6, 7, 8, 9 devices, switches and routers, IP address and model or platform. One, two, three, 4, 5, 6, 7, 8, 9. Use a script to request a list of host devices. Okay, the programmer chooses a list of specific information for each of the 6 host devices connected to the network. Run the file number 3, get hosts. Okay, review the file number 3, JSON request URL. The difference is here, host, the same token, request, the URL, the headers, verify false, print the code, the status code, and the response, and use the for to get the response, show host name, show host IP, show MAC address and connected interface name. Okay, run the file. Python 303, press tab to complete, get host, enter. Okay, 1, 2, 3, 4, 5, 6 end devices, IP, MAC address, and the interface connected to the network. 1, 2, 3, 4, 5, 6 devices, end devices. Send REST requests inside Packet Tracer. You will use the same scripts with one small edit to send the same API requests inside Packet Tracer that you send from Visual Studio Code. Create a project in Packet Tracer. In Packet Tracer, click the admin PC. In Packet Tracer, click the admin PC. Packet Tracer, click the admin PC, this PC. Click Programming tab. Go to Programming tab. There is currently no project. Click New. New. Enter REST APIs as the name and choose empty Python as the template. REST APIs template empty Python. Be careful, empty Python. Click Create. Click on Create. The REST APIs Python project is now created with a blank main script. Okay, this is the main script, it's blank. Modify the scripts to run inside Packet Tracer. Access from one application to another on the same host machine requires that the port number be specified in the URL. However, Packet Tracer is simulating a real network. In the real world, you do not normally specify the port number when making API requests. In addition, you would use a domain name or IP address in the URL. In Visual Studio Code, copy the code for the 03 get host file. Select on Visual Studio Code, select the third file, 3 get host, and copy all this. Copy. In the Admin Programming tab, double-click the main script to open it. Paste the code in the main script. Okay, here on Admin, double-click on main, double-click, and now you can see cursor and or use this button paste. Okay, very nice, be careful. Change the API URL, replace localhost 58,000 API v1 host with 192.168.1.1.254. Okay, use the IP address of the controller 192.168.1.1.254. Go to admin again and replace here. Instead of, okay, I will use instead of localhost, use 192.168.1.1.254, the IP address of the controller. And don't forget, do not use the port. Okay, remove the port. So the URL should be http://192.168.1.1.254 API v1 host. Edits are automatically saved. Click Run. Packet Tracer output does not exactly simulate what you see in the Linux command line. However, you should see similar outputs. Okay. Up here, Run. You can see the output. PC4, PC3, PC1, PC2, admin, and example server. Very nice. And copy and paste the get network device file into the main, change the URL and run it. Okay, on Visual Studio Code, go to the second file, copy this get network devices, copy, and remove this and paste. Okay, network device, but modify the URL, the IP address of the server 192.168.1.1.254. Remove the port, so the URL will be http://192.168.1.1.254 API v1 network device. Okay, and get the host name, platform ID, management IP address, and up here run. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 devices, platform ID or model and IP address. Okay, very good. Thank you very much.